Welcome to practical 7, which is on composite wall thermal analysis. So in this we are going to analyze this composite wall which is having three different material, and we are going to study the heat transfer across this wall, right? So on one of the hand there are hot gases flowing. At other side we are having the environmental temperature. So we are going to study how the heat transfers takes place throughout this wall. So this is a problem statement given, composite wall thermal analysis. A composite wall consists of three material as shown in figure K1, K2, K3. The outer temperature is 20 degrees Celsius. So in right hand side this temperature is 20 degrees Celsius, atmospheric temperature. We can consider this side is atmosphere. The inner side is a hot side which is having a convective heat transfer taking place at T infinity equals to 800 degrees Celsius and convective heat transfer coefficient of 30 watt per meter square degree Celsius, right? So we'll consider there is inside and there's another wall. Let's consider this as a furnace. So outside furnace temperature is 20 degrees Celsius. Here inside we have hot, assume it's gases, hot gases at 800 degrees Celsius and convective heat transfer coefficient of 30 watt per meter square degree Celsius. We have to find the temperature distribution across the wall, right? And K1, K2, K3 values are given. K1, K2, K3. The thicknesses are 300 mm, 200 mm and 150 mm respectively. So as you already aware that when we have solved first 6 problem, it was based on a structural mechanics. So in structural mechanics, the governing equation is generally given by this K into U equals to P, like this is what we have discussed in early lectures, where K is a stiffness matrix, U is a displacement matrix, P is a load matrix. When we talk about heat transfer, the matrix changes. It becomes K into temperature matrix, let's say T equals to Q, heat transfer rate. So K is thermoconductivity matrix, T is temperature, which is primary variable in heat transfer. In structural mechanics, primary variable was deformation, is equal to Q here. So this K is changing according to mode of heat transfer. So if it is only a convection, then only conductivity will come in picture. If it is a convection and conduction both, then K and H both will come in a matrix equation, right? So this changes according to modes of heat transfer. In our case, it will be K as well as H, conductivity and convection, both things will happen here, right? And based on that we'll get the heat transfer rate. There is no internal heat generation load, so it's only the external loads here. If it is there, then QI, internal heat generation load, we can take here. So now let's see how we can solve in answers in the next video.